Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. This episode focuses on the internal component replacement procedures commonly performed on laptops, specifically involving batteries, keyboards, and memory modules. These are some of the most frequent tasks encountered in IT support roles and are often tested on the A+ exam through step-based scenarios. Candidates must understand how to handle these upgrades safely, correctly, and with an awareness of the tools and components involved. Mastering these skills ensures readiness for real-world maintenance as well as exam success. Laptop battery types most often encountered include lithium-ion and lithium polymer technologies. Lithium-ion batteries are widely used due to their balance of capacity, efficiency, and lifespan. Lithium polymer batteries offer more flexible designs but require specific handling to maintain safety and prevent damage. Candidates should understand how these battery types differ in charging behavior, failure symptoms, and replacement procedures. Recognizing warning signs of battery issues, such as rapid discharge or swelling, may appear on the exam. Proper battery removal and installation follow a specific sequence that ensures both safety and equipment protection. The process begins with powering down the device, unplugging it from any power source, and discharging static electricity. Removable batteries often include locking sliders or release tabs, while internal batteries require disassembly of the laptop casing. CompTIA may present these tasks as scenario questions, asking for the correct order of operations when replacing a power cell. Keyboard replacement involves greater complexity and requires familiarity with laptop construction. Most procedures begin with removing retaining screws and separating the keyboard bezel or upper chassis. Ribbon cables connect the keyboard to the system board, and these connectors must be disengaged with care. Some keyboards are easily removed, while others are integrated and demand additional disassembly. The exam may ask about identifying connectors or differentiating between installation methods. Safety precautions are especially important when replacing a keyboard. Anti-static wrist straps and clean workspaces reduce the risk of electrostatic discharge, which can damage internal components. Care must also be taken not to damage surrounding parts such as touchpads or internal cables. Applying proper torque when reinstalling screws ensures the unit is secure without causing strain. Safe handling practices may be included in exam questions focused on installation scenarios. Laptops use a specific type of memory known as small outline dual inline memory modules, or SODIMMs. These modules are physically smaller than standard desktop RAM and are designed to fit compact mobile form factors. The exam may ask about common types such as DDR3 and DDR4, including their voltage, speed, and capacity differences. Understanding memory specifications helps with both upgrades and compatibility troubleshooting. To access laptop RAM slots, technicians often remove a bottom panel secured with small screws. In some models, access is gained through the keyboard area. Plastic spudgers and precision tools are used to open the casing without causing damage. Candidates should recognize slot orientation, avoid touching contacts, and align modules according to the notch placement. Installation questions often focus on slot access and proper tool usage. Installing RAM involves aligning the module's notch with the slot and applying even downward pressure until it clicks into place. Once installed, the system should be powered on to verify recognition. During startup, the BIOS or operating system may display the new memory total, confirming successful installation. The exam may test whether candidates know the proper steps and signs of a successful memory upgrade. Compatibility is a key concern when upgrading memory. Using RAM with mismatched speeds, voltages, or generation types can lead to system instability or boot failure. Some systems may not recognize higher capacity modules due to BIOS or motherboard limitations. The A+ exam may include questions that describe an upgrade scenario and ask whether the components selected are compatible. Understanding these limitations is vital for support roles. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. The BIOS, or UEFI, plays an important role in recognizing newly installed RAM. When the system boots, the memory count is often displayed on the initial splash screen or available within the system's setup interface. In some cases, manual configuration within the BIOS may be required to ensure full recognition. If memory is not detected properly, diagnostic tools or BIOS settings can help isolate the issue. Confirmation through BIOS visibility is a reliable indicator that the hardware installation was successful. Improper installation of RAM can lead to several noticeable symptoms. These include a failure to boot, repeated beeping sounds during startup, or a blank screen. In some cases, the system may boot but show less memory than expected. These issues can result from modules not being fully seated, incorrect slot usage, or physical damage to either the module or the slot. Identifying and correcting these errors is part of standard troubleshooting during a memory upgrade. When upgrading RAM, following a safe and deliberate process is essential. The technician should first verify the system specifications and confirm compatibility with the new memory modules. Backing up important data is always a prudent precaution. Anti-static protection such as wrist straps and grounding mats should be used to prevent electrical discharge. For added caution, upgrading one module at a time allows for easier identification of problems if issues arise. Understanding the difference between single-channel and dual-channel memory configurations is also important. Dual-channel setups use paired memory modules installed in specific slot configurations to improve performance. Visual indicators or slot color coding may assist with identification. Matching module specifications, including size and speed, is required for dual-channel mode to function correctly. The exam may ask about memory performance or proper installation using slot labels. Keyboard form factor and layout differences also matter when selecting replacement components. Regional layouts, such as US versus UK keyboards, have distinct key arrangements. The replacement part must match the original layout to avoid usability issues. Additional considerations include whether the keyboard features backlighting or function keys, which may require specific models or firmware support. Incorrect replacements can lead to input errors or disabled features. Post-installation testing verifies whether upgrades were successful. After reassembly, the system should power on and complete its boot process. For keyboards, each key should be tested to ensure proper input and responsiveness. Operating system recognition of newly installed RAM confirms correct seating and configuration. Any instability, such as freezing or slow response, may indicate an installation issue that needs to be revisited. Support documentation such as service manuals and technical diagrams is essential for upgrade procedures. These manufacturer-provided guides show how to disassemble, handle, and reassemble specific laptop models. Using official documentation ensures proper screw placement, cable routing, and part compatibility. CompTIA may test a candidate's understanding of why these resources are valuable during maintenance. Common tools used in battery, keyboard, and RAM upgrades include Phillips and Torx screwdrivers, plastic pry tools, tweezers, and anti-static gear. Tools should be appropriately sized, non-conductive, and clean. ESD wrist straps and grounding surfaces prevent static buildup, while tweezers aid in precise cable management. The exam may ask about tool selection or the purpose of specific instruments during disassembly tasks. To summarize, upgrading laptop batteries, keyboards, and memory modules involves a combination of physical precision, safety awareness, and hardware compatibility. Technicians must follow structured procedures, use appropriate tools, and verify all changes through testing. These tasks represent core competencies in mobile device maintenance and support environments. For the A+ exam and future job roles, Knowing how to perform these upgrades correctly is both practical and essential. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.